Okay, so we're going to look at some examples of using implicit differentiation. So we talked in the last video about the two main steps for implicit differentiation. Differentiate both sides with respect to x. So we're going to apply a d dx to both sides of the equation. And when we do that and you differentiate functions involving y, that's where you actually use chain rule. You have this extra factor of dy dx. And then the last main step is to use algebra to isolate dy dx. So two main steps in this problem. We're going to notice, first of all, that this is a problem where we should be using implicit differentiation, because if I want to find dy dx, I'm going to notice that I have a y squared here and a y here, so I can't algebraically solve the equation for y before I start finding the derivative. So I need to use implicit differentiation, so I'm going to start by differentiating both sides with respect to x. Okay, so what I've written down there is just instructions telling me to differentiate both sides of the equation with respect to x. On the left side of the equation, the first thing I might notice is that this first term has an x squared in it, and it also has a y. And since we're finding dy dx, we're treating y as a function of x. So in this first term here, I'm actually going to need to use product rule. I'm going to have 3x squared times y squared, and so I'm going to need product rule on that part. And then when I differentiate the 4x term with respect to x, that'll be fine. And when I differentiate the right side of the equation with respect to x, I'll just need to remember to use chain rule there. Okay, so we're going to go ahead and set this up for product rule. We'll be taking the derivative of the first times the second function plus the first function. And then when I take the derivative of the second function, that's where I'm going to need to really be using implicit differentiation here in chain rule. So this is the end of my product rule on this first term here. But this is where I'm using implicit differentiation. So when I'm differentiating y squared with respect to x, I'm going to use the property of bring down the exponent and subtract 1. So we'll have 2y. But then remembering that y is being treated as a function of x, this is where we are actually using chain rule. I have times that extra factor of dy dx. So anytime you're using implicit differentiation, and you're differentiating some expression involving y, of this extra factor of dy dx here from chain rule. All right, so all of that is from product rule. And then I'm going to have plus the derivative with respect to x of 4x. That will just be 4. And then on the right side of the equation, I'll be using implicit differentiation again, so there'll be some chain rule involved here. So the derivative with respect to x of the outer function, derivative of sine, is cosine, and leave the inside alone. And then times the derivative of that inner function. So that's where I have the extra dy dx factor. Okay, so I've now completed this step, differentiate both sides with respect to x. I applied d dx to both sides of the equation. I did that and rewrote it. And then we're going to use some algebra to isolate the dy dx. Before I do that algebra, I'm going to just tidy up the left side of this equation and remove some of these extra parentheses that I don't really need here. So I'll have 6xy squared. On this next term, I'm going to go ahead and multiply the coefficients together to make that 6x squared y dy dx plus 4 equals. And I'm going to just put the dy dx in front on the right side of the equation so it's clear that the cosine only applies to y and not to dy dx. Okay, so from here, I'm just going to use some algebra to isolate the dy dx. So this step is the same every single time. The functions that are in your problem look a little different every single time, but that algebra, two main steps to that algebra. One, add and subtract terms to get all the dy dx terms on one side and all the terms that do not involve dy dx on the other side of the equation. So we'll do that first. I'm going to notice that on the left side of the equation, I have 3 terms here. 2 of them do not involve dy dx, and 1 of them does. And on the right side of the equation, I have 1 term that involves dy dx. So I'm going to subtract this term from both sides of the equation so that I can get all the dy dx terms on one side. You don't have to write this algebra step out, but you should be thinking about what's happening here so that you're clear about how that term is moving to the other side of the equation. Okay, so what I have left on the left side of the equation is 6xy squared plus 4 equals, and then I have these two terms on the right side of the equation, so dy dx cosine of y minus 6x squared y dy dx. Okay, so the algebra is the same every single time. After you move all the terms involving dy dx to one side of the equation and all the terms that do not involve dy dx to the other side of the equation, the next step is always to factor out a dy dx, and then you're going to divide through by that factor that's left. So we'll have 6xy squared plus 4 equals. On this side of the equation, I'm going to factor out the dy dx, and I'm left with cosine of y minus 6x squared y. And then my goal is to solve for dy dx, so I'm going to divide through by this factor here. And I'll rewrite that answer over to the side here, and hopefully a little neater. Okay, so at the end here, we've got, I'm going to put the dy dx first. Dy dx equals, and then this expression that I have over here is my answer. All right, you want to be aware of the fact that if you are looking in the back of the book at answers that may be already provided or at an answer key or something like that, that there may be different forms of this same answer. So these two terms on the numerator could be written in the opposite order. Same thing with these two terms on the denominator. I would want to make sure that the minus sign is with the 6x squared y term though. And so there's different arrangements of these terms, just kind of using properties of algebra to rewrite that so that you've got commutative property and maybe some factoring sometimes, none on this one. But when you're doing online homework, the online homework system should be smart enough to recognize that you may have an answer in one form and other forms are also correct. But when you're checking answers with a printed answer key, sometimes you have to be aware of that difference.